Circular motion. When our body or particle moves on a path of circle, then it is called circular motion. It is an example of planar motion or two-dimensional motion. Consider a particle. Consider a particle moves from P to P direction in time delta t as shown in the figure. P to P time. Delta theta is called angular displacement of the particle. This is the reference line, this is the circular path, this is the origin, and this is the theta, the initial position, angular position of the particle. Theta is the initial angular position of the particle. Now average angular velocity is defined as the ratio of change of the ratio of angular displacement to the time interval, that is omega average equals to del theta by del t equals to theta 2 minus theta 1 divided by t2 minus t1. When del t tends to 0, delta t tends to 0, then the instantaneous angular velocity is omega, and given by omega equals to limit delta theta by delta t, delta t tends to 0 equals to d theta by dt. The ratio of change of angular velocity to the time interval is called the average angular acceleration alpha. That is alpha average or alpha bar equals to delta omega by delta t equals to omega 2 minus omega 1 divided by t2 minus t1. When delta t tends to 0, then the instantaneous angular acceleration is alpha equal to limit delta t tends to 0, delta omega by delta t equals to d omega by dt or equals to d2 theta by dt square. If the angular acceleration is constant, we can write kinematical equation in circular motion as, that is angular displacement equals to, that is theta equal to omega naught t plus half alpha into t square, where theta is the angular displacement, omega naught is the initial angular velocity, alpha is the angular acceleration, and t is the time interval. Similar to the linear motion as s equal to ut plus half at square, and omega equals to omega naught plus alpha t, where omega is the final angular velocity, omega naught is the initial angular velocity, alpha is the angular acceleration, and t is the time period. Similar to the v equal to u plus ct in linear motion, and omega square equals to omega naught square plus 2 alpha into theta, where omega is the final angular velocity, omega naught is the initial angular velocity, and theta is the angular displacement. Here same like in linear motion, v square equal to u square plus 2s. Now relation between angular velocity and linear velocity. The linear distance pp dash traveled by the particle in time delta t is ds equals to r into delta theta from the relation theta equals to l by r, that is arc length divided by radius. So or del s by delta t equals to r into del theta by delta t, or del s by delta t is the velocity, average velocity, delta theta by delta t is the angular velocity, average angular velocity, or into r. So v equals to r omega. This is the relation between linear velocity, radius, and angular velocity. Here v is the linear speed of the particle. Again, differentiating equation 4, dv by dt equals to r into d omega by dt, if r equals to constant, then this implies at equals to dv by dt equals to r alpha, d omega by dt equals to alpha. Here at is rate of change of a speed. This is called the tangential acceleration of the particle, and if v equals to constant, at equal to dv by dt equals to r into alpha equal to 0, that is alpha equal to 0, that is r is not equal to 0, that is angular acceleration will be 0 if speed is constant. Question: a particle moves in a circle of radius 20 centimeter with a linear speed of 10 meter per second. Find the angular velocity. Here given r equal to 20 cm equals to 20 into 10 to the power minus 2 meter equals to 10 meter per second, and v equal to 10 meter per second. We know that v equals to r into omega, hence omega, that is angular velocity, v by r equals to 10 by 20 into 10 to the power minus 2, 0.100 by radian per, so 50 radian per second, because omega has a unit radian per second. A particle travels in a circle of radius 20 centimeter at a speed that uniformly increases. If the speed changes from 5 centimeter per second to 6 meter per second, 5 meter per second to 6 meter per second in 2 seconds, find the angular acceleration. Here r equals to 20 cm, 20 into 10 to the power minus 2 meter in SI unit. v1 5 meter per second and v2 final velocity 6 meter per second, and delta t equal to 2 seconds. This time interval velocity change, that is a speed change. Formula: tangential acceleration will be dv by dt equals to v2 minus v1 by dt equal to 6 minus 5 by 2, or 0.5 meter per second square. Now the angular acceleration is alpha equal to at by r, where it is the tangential acceleration. So angular acceleration will be 0.5 over 20 to 10 to the power minus 2 radian per second square, solving 2.5 radian per second square. Vector's relation between linear velocity and angular velocity. When body moves on a circular path, then the angle traversed during the given time interval, that is d theta, direction is along the axis of rotation, that is d theta direction will be along z axis if circular path is in xy plane, and this is the point P and this is the P dash, that body has moved from P to P dash in circular path. So this will be displacement, linear displacement, and it is in xy plane, and this is the radius vector. So we have relation, here it is shown, d theta in perpendicular to this plane, r vector in this plane, and dr vector in this direction. Now if we take cross product of d theta and r vector, then its direction, d theta cross r, the direction of d theta cross r will be along the direction of dr vectors. Now consider a particle at the position P in the body. As the body rotates, let the particle moves from position P to P dash such that its linear displacement is pp dash vector equal to dr vector and angular displacement d theta vector. So we can write dr vector equals to d theta cross r vector, because the direction of dr vector and the direction of d theta cross r vector in same direction. And from the triangle law we know that arc length is equal to the theta into radius, so this relation, or dr by dt equals to d theta by dt cross r vector, or v vector equals to omega cross r vector. The direction of again omega will be in along z direction, and v and r will be in xy plane. unit vector along the radius and the tangent. Consider this is a circular path placed in the xy plane, and z axis is perpendicular to this plane, that is in upper direction. So consider a point P at this point. The radius vector is along this, so unit vector will be along this, and it is represented by ER vector. Again, tangent to this point is in this direction, and the unit vector along this, that is tangent direction, is ET vector, represented by ET or ET cap. Now you will fix the x-axis at this point. So x dash axis will be parallel, these axes are parallel, so you can consider that is x dash in this direction, y dash in this direction. Consider OP vector to R vector, that is radius vector of point P. So PA cap vector, that is ER cap vector, is the unit vector along increasing radius, or E cap T vector equal to PV cap is the unit vector along the tangent along the tangent in the direction of increasing theta. From figure, PA cap we can write here from figure, if this represents unit vector, that is ER cap, then PA cap will be equal to mode of PA cap into cos theta I cap plus mode of PA cap into sin theta j cap from the component on. So we can write ER vector, this is also unit vector, or ER cap you can write. Cos theta, because mode of PA cap, because it is a unit vector, so its magnitude will be 1, and this will also will be 1. Hence ER vector equal to cos theta I cap plus sin theta j cap equals to mode of PA cap, because mode of PA cap is equal to 1. This is equation 1. So unit vector along radius vector will be represented by this formula, that is this represent unit vector along radius vector, which is equal to cos theta I cap plus sin theta j cap. Similarly, PV vector, which is a unit vector along tangent, which is a unit vector along tangent, we can write PV sin theta equal to minus I plus PV cos theta into j cap, or minus of PV sin theta I cap plus PV cos theta j cap. Since PV equals to, that is the magnitude of PV, which is a unit vector, so magnitude will be 1, so minus sin theta I cap plus cos theta j cap. Equation 2. Next, acceleration in circular motion. In the above figure, the position vector of particle at P is R vector equal to OP vector, or OP into ER vector, that is magnitude and unit vector. Now OP is equal to R and unit vector is equal to cos theta I plus sin theta into j cap. This is equation 3. Differentiating with respect to time, differentiating this equation with respect to time, we will get dr by dt equals to d by dt under bracket r into under bracket cos theta I plus sin theta j cap, or r equals to d cos theta by dt into I cap plus d sin theta by dt into j cap, or r into d cos theta by dt into d theta by dt into I cap plus d sin theta by d theta into d theta by dt into j cap. Now d cos theta by dt equals to minus sin theta, and d theta by dt equal to omega, that is angular velocity, I cap d sin theta by dt cos theta, and this is omega. So we have r vector as this formula, r equals to under bracket minus sin theta omega I cap plus cos theta omega j cap. This is the, and dr by dt is the linear velocity, so we can write v vector equal to dr by dt, or r omega into minus of sin theta I cap plus cos theta into j cap, and this represent ET cap, that is tangential unit vector. This is equal to the tangential unit vector. You can see that tangential unit vector. So we can write this formula as v vector equal to r omega into et cap, where et cap is the tangential unit vector, equation 4. Thus from 4 we see that the velocity of the particle is along the tangent and its magnitude is r omega. Now the acceleration a vector equal to dv by dt r omega into minus sin theta I cap plus cos theta j cap equals to r into d omega by dt minus sin theta I cap plus cos theta j cap plus omega into dy dt minus sin theta I cap plus cos theta j cap, or I into d omega dt, or this is equal to et cap plus omega into, again differentiating this, minus d sin theta by dt I cap plus d cos theta by dt into j cap, or r into under bracket d omega by dt et cap or et vector plus omega into, you can see 18 minus d sin theta by d theta into dt I cap plus d cos theta by dt into dt by d theta by dt into j cap, r into under d omega by dt et cap plus omega into under bracket minus cos theta into omega I cap plus minus sin theta into omega j cap. Omega can be taken out of the bracket, so equals to r into whole under bracket d omega by dt et cap or et vector plus omega square. When we take omega, this will be multiplied this, so omega square into minus cos theta I cap minus sin theta j cap. Now take minus out of the bracket. This will be r d omega dt into et cap minus r omega square into cos theta I cap plus sin theta j cap. Now this is the unit vector along radius, radial unit vector. So we can write r d omega by dt et cap minus r omega square into er cap, or dr omega by dt, this can be written as dr omega by dt into et cap minus omega square r into er cap, or from this we get minus omega square r into er cap plus dv by dt, because this is called r omega is equal to v, here r omega equal to v, so dv by dt into et cap. So we have a vector equals to minus omega square into er cap plus dv by dt into et cap. So this term shows that the one part of acceleration is along radial vector, that is toward the center, and another part is another part of acceleration into along the tangential direction. So this is written as a vector equal to ar plus at, where ar is called radial acceleration and at is called tangential acceleration, where ar equal to minus omega square into er cap is the radial acceleration of the particle, and at dv by dt into et cap is the tangential acceleration of the particle. Now magnitude of net acceleration will be given. Here it is shown that situation. This represent at, that is at is the magnitude, at is equal to dv by dt. V is the speed, that is varying speed, and ar is the omega square r, that is radial acceleration in this direction, which is equal to the v square by r square into r, that is v square by r, and both are perpendicular to each other, so its direction resultant will be in this direction, a vector, and a vector will be given as the magnitude of net acceleration is mod of a vector equal to under root at square plus ar square, under root dv by dt का whole square plus omega square r का whole square, or under root dv by dt whole square plus v square by r का whole square.